Good evening, dear students. Now I want to discuss the paradox of fractional oxidation states from redox reactions lesson. This is a very important concept for NEET and JEE aspirants. First one, carbon suboxide. Its chemical formula C3O2. You can assume carbon oxidation state, that is X, 3X, plus 2 into oxygen oxidation state minus 2. 3x minus 4 equal to 0. 3x equal to 4. X equal to 4 by 3. 4 by 3 means 1.33. Mathematically, we can calculate like. Answer here 4 by 3 or 1.33. Both are correct. Now, based on structure. You know, carbon valency 4. That means carbon maximum can form 4 covalent bonds. Each carbon having 4 covalent bonds. Yes, right. Oxygen satisfied with double bond. Yes. So now, how can we assign oxidation states for individually? First, we can start from more electronegative atom and terminal atom. More electronegative atom. So we can assign oxidation states for more electronegative atoms and terminal atoms. We can start from terminal. Oxygen minus 2. Oxygen minus 2. So oxygen minus 2 means before, definitely it should be plus 2. Before plus 2. You know, one atom connected with two similar atoms means its oxidation state 0. Remember. One atom connected with two similar atoms means its oxidation state 0. So its oxidation state 0. Clear? So now, average oxidation state of carbon equal to how many carbon atoms total? 3. 3 carbon atoms. Terminal carbon atom 2. Middle carbon oxidation state 0. Again terminal 2. So 4 by 3. 4 by 3 means 1.33. 1.33. Understood everyone? Yes. Very important it is. You can ask one doubt. Sir, based on mathematically and based on structure, we are getting same answer. Then what is the use of structure? So many times asked, particularly NEET and JEE main also. What are the oxidation states of terminal carbon atoms in carbon suboxide? Plus 2 and plus 2. Like asking question. What is the oxidation state of middle carbon atom in carbon suboxide? 0. Individually asking. That's why structure is very important. Based on structure, identification of oxidation states very important. Clear? So now coming to second structure. Tribromo octoxide. Chemical formula Br3O8. You know, it is NEET 2019 question. This one asked in NEET 2019. In NEET 2019, just its structure asked. Okay. What is the structure of tribromo octoxide asked? So now, 3 bromine atoms. 3x plus 8 into oxygen oxidation state minus 2 equal to 0. 3x minus 16 equal to 0. 3x equal to 16. X equal to 16 by 3. X equal to 16 by 3. Then x equal to 5.33. Okay, 5.33. So mathematically we got like. Now, based on structure, 3 bromine atoms. We can write like 3 bromine atoms. Now 8 oxygen atoms. Eight oxygen atoms. Among the 8, 6 oxygen atoms we can write like. Now this bromine. Around the bromine, how many covalent bonds are there? 7 covalent bonds. Here 7 covalent bonds. You know bromine group number 17th or 7th A. So 7 valence electrons. So bromine maximum can form 7 covalent bonds. Yes, correct. Now remaining 2 oxygen atoms we can write like. So here bromine. Around the bromine, how many bonds are there? 6 covalent bonds. It can form maximum covalent bond 7. So here 6. So less than 7. Yes, possible. So this is the structure. This is the perfect structure. Now already I told you first we can assign terminal atoms and as well as more electronegative atoms. Oxygen -2, -2, -2, -2, -2, -2. Like we can assign terminal atoms. We can assign terminal atoms and more electronegative atoms. Clear? Now temporarily we can remove these 2 oxygen atoms. Okay, temporarily we can remove. Already I told you 2 similar atoms attached. Bromine attached to 2 similar atoms. Then its oxidation state 0. Okay, bromine attached to 2 similar atoms, its oxidation state 0. Yes, we can write here 0. Understood? Its oxidation state 0. Bromine attached to 2 similar oxidation states. Now sum of the surrounding oxidation states. Sum of the surrounding oxidation states. -2, -2, -2, 0 means -6. Then bromine should be +6. Okay. Sum of the surrounding oxidation states. Sum of the surrounding oxidation states. -2, -2, -2, 0, -6 means bromine should be +6. Clear everyone? Understood? Very, very important. Okay. Assigning oxidation states for individual atoms. Very, very important. Now coming to middle bromine atom. Coming to middle bromine atom. Now you can write 2 oxygen atoms like. Now surrounding oxygen atoms -2, -2. Then bromine should be +4. Clear everyone? I hope everyone understood. Oxygen -2, -2 means bromine. -2 plus -2 means -4. Bromine should be +4. So this is the procedure for assigning oxidation states for individual atoms. Now average oxidation state of bromine. Total bromine atoms 3. Terminal bromine, middle bromine, terminal bromine. Now 16 by 3. 16 by 3. Now 5.33. 5.33. Understood? This is the procedure for calculation of average oxidation state of bromine, mathematically based on structure. I told you what is the importance of structure. So nowadays asking oxidation states for individual atoms. So expecting question, what are the terminal bromine atoms, their oxidation states in tribromo octoxide +6 and +6. What is the oxidation state of middle bromine atom in tribromo octoxide +4. Clear? Now moving to last example. Third question. Tetrathionate. tetrathionate S4O6 2 minus tetrathionate. Now 4 sulfur atoms 4x 6 into oxygen minus 2 is equal to charge minus 2. 4x minus 12 equal to minus 2. 4x equal to 10. X equal to 10 by 4. X equal to 5 by 2. X equal to 5 by 2. Then X equal to 2.5. So what is the oxidation state? 2.5. Average oxidation state of sulfur 2.5 or 5 by 2. This is mathematically. Now based on structure, 4 sulfur atoms. We can write like 4 sulfur atoms. Now 6 oxygen atoms. 6 oxygen atoms. 3, 3. 6 oxygen atoms. 2 negative charges. This is the structure. Okay. So now already this is minus 2. Sorry, this is minus 1. This is minus 1. Charge is oxidation state. Minus 1, minus 1. Now we can start from more electronegative atoms, terminal atoms. Minus 2, minus 2. Minus 2, minus 2. Already I told you. Sulfur attached to 2 similar sulfur atoms. Sulfur attached to 2 similar sulfur atoms. Its oxidation state 0. This sulfur attached to 2 similar sulfur atoms 0. This sulfur attached to 2 similar sulfur atoms 0. Clear? So now surrounding sum of the oxidation states minus 2, minus 1, minus 2, 0. So minus 5 means it should be plus 5. Surrounding sum of the oxidation states minus 2, minus 2, minus 1, okay, minus 1. This is, okay, minus 1, 0. Minus 2, minus 2, minus 1, 0 means minus 5. This should be plus 5. Clear everyone? Now, average oxidation state of sulfur equal to how many sulfur atoms? 4. 5 plus 0 plus 0 plus 5. 10 by 4. 5 by 2. That means 2.5. Clear? 5 by 2 or 2.5. Understood? So very important. What is the average oxidation state of sulfur in tetrathionate? 2.5 or 5 by 2. But here we can expect a question like, what are the oxidation states of terminal sulfur atoms in tetrathionate? Plus 5 and plus 5. What are the oxidation states of middle sulfur atoms in tetrathionate? 0 and 0. Understood? So how many examples we have done? 3. Carbon suboxide, tribromo-octoxide, tetrathionate. In NCERT textbook, in our syllabus, there are only 3 paradox of fractional oxidation states. For NEET examination and JEE mains, directly asking from these 3 examples. Understood? So please concentrate on these 3 compounds, and once please focus how to assign individually oxidation states. Clear? Thank you. Thank you.